This is everything you need to know to pass the 11MTN measurement assessment. You need to demonstrate 3 measurement skills. The first one is surface area. Surface area is the area that's on the outside of a 3D object. For example, in this shed. Calculate the area of paint required to paint the entire shed, excluding the bottom panel. That means I need to know how much space is on the outside of this 3D object. Now this 3D object on the outside is just split up into rectangles and a triangle. And I can use that to find the total area. So the way I do it is I label the different panels that I can see. And the reason that I label them is so that I can do my calculations and it's very clear what I'm doing. So for example, for panel 1, I can see that this here is a rectangle. So I can go to my formula sheet if I wasn't sure, and I can see that the area of a rectangle is BH, which means base times height. So in this case, it would be the base, 6.2, times the height, which is 3. And this would give me 18.6. Now, it's really important that at each step you are showing a calculation. And so this is a really nice method because I can clearly see the calculations that I'm doing. For panel 2, this would be, here's my base of this rectangle. It's 15. So 15 times my height here, which is 3. So 15 times 3 is 45. For panel 3, I can see it's still a rectangle. And I can see its height, but I'm not sure what its base is at the moment. But I can find the same information somewhere else on my diagram that shows what this length is. Down here is the exact same length. So that's going to be 15. So for panel 3, the base is 15 times 2, the height, and I get 30. For panel 4, I can see that it's a triangle. So I look at my triangle formula here, and it says half base times height. Now, I'm going to use 0.5 to represent half, because it's really easy to type in my calculator if that's what I'm using. Now, this is the base of the triangle, and again, it's not written there exactly, but I can see that on a different place of my diagram, I've got the exact same length, so it's going to be 6.2. So half times 6.2 times the height, and in this case, the height is 1.5. Now, there's some tricky numbers in here, so don't be afraid to use a calculator. You can just chuck it in, 0.5 times 6.2 times 1.5, and it tells me that it's 4.65. Now, I want to know the total surface area, so that's all of these panels combined. So I'm going to add them up. 18.6 plus 45 plus 30 plus 46.5. 4.65. And again, I'm going to use my calculator here. So 18.6 plus 45 plus 30 plus 4.65 gives me 98.25. Now, this answer here isn't the final answer. It's only half of what I need to show for my surface area. Because for each of these panels, there's an exact copy on the other side. We can clearly see this with the roof. So here's panel 3, and there's another panel that's an exact copy of panel 3. Similarly, there's going to be a triangle panel at the back, and another rectangle at the back, and there's another rectangle on the side, and they're all copies of the panels that I've found already. There's 2 of each. So I can take my final answer, and I'm going to multiply it by 2. And that gives me 196.5. So the total surface area, and just see that I'm labeling this as well. Everything should be labeled and have calculations, is 196.5 meters squared. The unit is important. You must have the unit. Now it's meters squared because we're looking at area. Even though it's a 3D object, we're looking at the area of the 2D surfaces. The second skill is volume, specifically volume of a cylinder. Now again, I can go back to my formula sheet and it tells me what the volume of a cylinder is here. So calculate the volume of this pipe. Well, if I unpack this formula here, pi is just a number I can find on my calculator, and I need to multiply it by the radius squared, which just means radius times itself, times by the height. So I need to know what the radius is and what the height is. Now I can see we've got this circle part here at the top, and that 1.2 going across there represents the diameter. So if the diameter is 1.2, the radius is half the diameter. So if I wasn't sure how to half 1.2, I could just chuck it in my calculator. 1.2 divided by 2 gives me 0.6. So the radius is going to be 0.6. So if I was doing the volume here, I would go pi in my calculator times 0.6 times 0.6 times the height, which I can see from my diagram is 1.8. And I'm just going to chuck that in there now. Pi times 0.6 times 0.6 times 1.8. And I get a big number here, 2.035752, and it keeps going. Now I'm just going to round this to 2 decimal places. So this would be 2.04. And that's because I want 2 decimal places, but the third one, because it's 5 or higher, bumps this 3 up to a 4. If this third one was less than 5, it would just stay as a 3. And this one, because it's a volume, how much 3D space is taken up would be meters cubed. Again, the unit is necessary for passing. And then the last skill is the perimeter. Now this sort of comes in a kind of interesting way. So it says here, calculate the perimeter of the fence if the fence is placed 16 meters from the playhouse in all directions. So what that means is the distance between the playhouse and the fence is going to be 16 meters. And it doesn't matter what side I'm on, it's always 16 meters. And what I can do is I can use that information. So if I was starting here in my corner and I want to go, the perimeter is the length around the whole side. So I need to go all the way around. But if I was just to go up from here to here, because this is from the fence, the top fence, to in line with the playhouse, this would just be 16 meters. And then if I was going across the playhouse, I can see that this lines up with the playhouse, and it tells me that that's a distance of 6.2. And then again, from the playhouse to the fence would be 16. And if I add those all up, I can see that the total length on this side would be 38.2. That's just 16 plus 6.2 plus 16. I can do something similar on this side, on the bottom here. So this distance is going to be 16, because it's the distance from the fence in line with the playhouse. This distance in the middle will be 15, because that's what it says here is the length of the playhouse. And then finally, the distance from the playhouse to the fence again is 16. So if I add all those up, 16 plus 16 is 32, plus 15 would give me 47. Now, because it's a rectangle, this will be 38.2 as well on this side, and this will be 47 here. So the perimeter will be the addition of all of those, the sum. So I would go 38.2 for that side, 47 plus 38.2 plus 47. And I'm going to chuck that in my calculator again, 38.2 plus 47 plus 38.2 plus 47, and that gives me 170.4. Now this one's just meters because it's just a length. So to recap those units for any kind of area, even though this is a 3D object, we're not just looking at the surface area, so it's meters squared because it's the space of a 2D shape, these rectangle and triangle panels. Volume is meters cubed because it's how much 3D space it takes up. And perimeter is just a length, so it's just meters. And if students, or if you are the students rather, can demonstrate these 3 skills, finding a surface area, a volume of a cylinder, and this perimeter, then you will be able to pass your measurement assessment.